So, good morning, students.
Good morning, sir.
Let me start. Although attendance is very poor, but anyway, I'd like to conclude numeric arrays today so that Joydeep sir can take up character arrays from next week. Okay, so is my slide visible?
Yes, sir.
Okay, so
Yes,
yes, hello. Okay, so let us start. As I have mentioned in the last class, that we'll be dealing with sorting an array. How to, we'll be trying to write programs so that we can sort in some order. Given an array in an arbitrary ordering of elements, like say we start with an array with elements like this.
Sir, sorry to interrupt, sir. Have you started the recording?
Yes, I have already started using OBS. Yes.
Okay, sir. Thank you.
Okay. So, for example, let us take this is our initial array. Huh. Now see, for simplicity, I have taken only numbers. But remember that these entities or these member elements may have any value, but they should be comparable with each other. So we'll be dealing with comparison based sort. That means any element whose values can be compared. Like we can have an A, B, C, D like that. Huh? And then we would like to arrange in the order of the alphabetical order. That is also allowed. But for simplicity, we are taking only integer. But anything whose any object maybe some weights which can be compared. So in not necessarily be there should be number or integers. Okay. But for simplicity, we are assuming that we have been given an initial array which is not order in any order, either ascending or descending. Now suppose without loss of generality we have to order it in ascending order, sort it in ascending order. So what will be the desired output? It will be not like 3. So smallest element is 1, then 2, then 3, then 4, then there is a 5, 6, 7, 8 and 9. So how we can write a C program or any other language that given an array, arbitrary array we call. We don't know, um, what order, whether they are at least at all ordered in some sequence or not. Finally, we have to make them ordered. Okay. So as I mentioned in the last class, we have a natural strategy that very popular in our real life, that we call this strategy. When we employ this strategy for sorting the cards in our hand. Okay. And as I mentioned in the last class also, that we can mimic that to find out a very intuitive sorting algorithm that is named as insertion sort. In the last class, what we have done, we have learned how to insert a new element into already sorted sequence. Like we have already a sub array which is already sorted, and if we have a new element, we can easily place that element in a proper sequence such that the modified array becomes sorted. That part we have already learned. And see, this part of the pseudocode represents that, isn't it? If you just match with the pseudocode of the last class, then you will be able to see. This is the condition based on which this loop gets iterated, and finally when this particular position of the new element to be inserted is found after the while loop gets terminated, and finally this statement actually insert the new element in its proper position such that after inserting that element, that new partial array whose size become just one more than the earlier also sorted. Now it is very intuitive to understand that if we can repeat this step starting with the empty array, analogically similar to start with an empty hand, and if we employ this strategy for each of the incoming elements one by one or incoming cards, okay, that is being done by this for loop. Understood? So I am starting with an empty, as if although I am given an array of element already, I am considering that first of all I would insert the first element, which will be trivial. Then I would insert the second element with this first element so that I can find a new array of two elements which is sorted. Now I will consider the third element and try to insert it in its proper position so that now I can get a little bit bigger array of three elements which is sorted. So I will be repeating this thing. Understood? So just try to understand the strategy. I am actually repeating this strategy for each and every element of the array starting from the 0th location. Okay, let me illustrate using this example. I have kept all the steps taking one example so that you can easily understand. You just go through this illustrative example. As I have already mentioned, consider this is our starting input. This is the arbitrary array we have got. We have to sort in ascending order. Now let us try to follow how this algorithm or solution strategy helps us to sort this. And do not get confined with this particular example only. Try to understand that this can be done on any input array of any size, with any number of elements, with any values of the elements, any order, whatever. Okay, let's see. So this is our given array. Am I audible? And are you getting? Just let me know so that I can.
Yes, sir.
Okay. Okay.
Yes, sir.
So what I am doing? So see this construction of this algorithm. We have a while loop which is enclosed within a for loop. So basically we have an nested loop. Now what I am doing? Initially, this is the key variable which I am taking, because by default the first element, when I have an empty array, by default that is sorted, I can say theoretically. Now when I am considering the first element is already sorted because I am just considering this size 1. I am not considering anything. So any element you give me, if the array size is 1, this is trivially be sorted. So I have to start from the second position, that means index 1 position, and that's why I have started from j equal to 1, not from j equal to 0. Okay, now what I am doing, so
Sir,
key
can
is
you repeat why
basically,
we start from second?
because see, I am starting, what I am doing, initially I am considering, if I had considered this 0, then what I have to do, I have considered only one size array. Whatever you put, whatever value you put, I can declare the array is sorted. Unless you get one more element, there is no need to change anything, isn't it? So whatever value is present, because I am going one by one, I am showing you initially. Suppose in the left hand side, first card you pick up, that you place. There is no need to compare where to place it. There is nothing in your left side. Now you have started with your empty hand, so you can place it anywhere in your left hand. Now whenever you pick the second card, then your decision making starts, that whether you need to put that on the right side of the older card or on the left side of the older card. So you need to start think when you are getting the second card. Similarly, you need to start working from the second element of the array, because first element by trivially it is sorted. Sorted means since we are considering that array size now is only 1. Now when we will increase the array size of 2, then I need to actually take care of their order. Understood? Clear?
Yes, sir.
Okay.
Yes, sir.
Okay. So that's why I have started from 1. Now what I am doing? I am taking this 4 value 4, whatever is there in the second element, in this temporary variable key. Okay. Now as if whatever I am doing here using this particular thing, because this portion of the code allow me to insert any new element in the already sorted portion of an array. Now for the first iteration of this for loop, already sorted portion of the array is this much, only this single element, and I have to insert this new element such that at the end I get an sorted array of 2 elements. That is to be done by the first iteration of the for loop. Understood? And since it is already so, when this is 4, now first time it checks this condition, it will be dissatisfied because already 4 is greater than 3. So nothing need to be done. So 4 will remain in its proper place, because if there were 2 or 1, then I had to iterate on this while loop. Fortunately, 4 is greater than 3. So automatically this while loop will terminate it at the first place. Okay. This is just for this particular example it is happening. For other example, maybe some iteration would have been 1. Now anyway, so 4 will be placed in its proper position, and now I can tell that I have already sorted this punch. That means I have got an array or partial array of 2 elements. Now for the next iteration of for loop, j's value is becoming 2. That means I am looking for third element and I would like to insert it into this already sorted portion of the array such that I get an array of sorted array of 3 elements. Again, since 6 is greater than 4, so first time it will be dissatisfied and nothing needs to be done. Automatically 6 will remain in its place, but I can now claim that I have sorted up to this much. I have already got a sorted array of 3 elements. The same thing, now value of j will be incremented by 1, and in the next iteration of the for loop, same thing will happen because 8 is also greater than 6. Okay, so it will be not doing anything, and value of j will again get incremented, and for the next iteration also similar thing will happen. 9 is greater than 8. Okay. Now after this 1, 2, 3, 4 iteration of for loop, we have got an partial sorted array of 5 elements already. And now j's value has become 5. Okay. This is the new iteration. We'll start. Now when j's value is 5, key will get this 7 value. Now see, now this while loop will be executed for finite number of time, because at the first place it is not going to dissatisfy. It is satisfying. I greater than equal to 0 because i's value is 5, and uh, this ai is greater than, I mean this 0, 1, 2, 3, 4. Oh, i's value is 4, and a4 is found to be greater than the key. So this portion will be executed. So what will happen? As we know, this 9 will be overwritten here because 7 is already kept somewhere else. So we can safely overwrite 7. That's why I have already copied 7 in another variable. Otherwise, if I overwrite 9, then 7 would have been lost. But that is not done here. So I will be overwrite 9 here. And the value of I will be decremented and it will now point to this. Again, this will be compared with this here. Again, both of these condition will get satisfied. So now what will happen? 8 will be overwritten here. 8 will replace 9 in this position safely. This is the already you know how this insertion takes place. In the last class I have discussed. Okay, so 8 will be now I is pointing here, and based on this comparison with AI, which is 6, and key 7, this will not satisfy. This will now dissatisfy. So this while loop now terminates, and when it terminates, this key value, that is the content of key, is now 7. 7 is now inserted because value of I now gets incremented again. So this position now that will point out, and 7 will be overwritten here. Okay. So see, this iteration of the for loop actually takes several iterations of while loop also. And after this long uh, execution of this iteration, we have got and partially sorted array of 6 elements. So it depends on the current value which I am inspecting. Based on that, the execution of these statements within this while loop, they may vary. Sometimes they may execute 0 time. Sometimes they may need to execute 1 time, 2 times, anything. Okay. So that is you need to know. Next, what will happen? 2. You can easily see now for this iteration of for loop, the execution of while loop will be the maximum number of times because 2 has to be placed before 3. So you can easily see when this is taken inside key and now your I is pointing here. So every time you compare with this AI, this particular thing will get satisfied unless and until you reach here. So in this way, it will be, you just follow the animation, you will be able to understand what is happening. So first time, since AI is greater than key, so this will be 9 will be overwritten in this place. Okay. Similarly, now I will be decremented on this, and then again AI and key, same thing will happen. 8 will be shifted towards right. Next, 7 will be shifted towards right. 6 will be shifted towards right. So in this way, the while loop is executing for the same for loop. 4 is shifted, 3 is shifted. Now when 3 got shifted, value of I now becomes 0. And from that, it once this last iteration of this while loop under this for loop gets executed, value of I become -1. And that forces this condition to be false. So this automatically this will be terminated. So -1 plus 1 a0. So key will be inserted here at the end of this. Understood? So in this way 2 gets inserted and this iteration of the for loop gets completed. Now we have got an array of, sorted array of uh, 7 elements.
Hello, sir.
Understood?
Yes, sir.
Okay.
Yes, sir.
So next, for 5, what will happen? See, now while loop will get executed for again some finite number of time. for this one, this one, this one, this one. Okay. So you follow the sequence, you will be able to understand. So first it will be compared with 9. Since 9 is found to be larger than 5, so 9 will be shifted towards right. Next 8 will also be shifted, 7 will be shifted, 6 will be shifted, and finally 5 will be inserted in this position. Okay. And lastly, this iteration, again it will be executing this while loop for last iteration of the for loop. The while loop will be executed for maximum number of times, because 1 is the smaller. I mean, we can see for this particular example, since it is presented by our, but our program does not see this. It has to just rely on these comparisons. Okay, but anyway, again I am just skipping these steps. So this will be going like this. All the shifting will be done for this particular example, because in our given array the smallest element was present at the rightmost side. Okay. So now, since we have already considered in up reached n minus 1, this for loop will get terminated, and finally we will be having the sorted array. And look at this, there is an interesting property of this sorting algorithm, which formally we call in place. Okay, that means we don't need any other array. Our one array was given, and we this algorithm runs in such a manner that within the same array I can reorder it properly to make it sorted in ascending or descending order. Okay. In some algorithm, there are some algorithms for which we need another array, another auxiliary array of size proportional to this input array. Those algorithms are called not in place. Okay. So from memory requirement point of view, this is more desirable. So in future, this comparison based sorting, there are 6 popular algorithms you may encounter. One I have discussed. Okay. You may heard this bubble sort. Hmm. Then there is another popular algorithm called selection sort. So these are, the strategy is little bit different.
Quick sort is there, sir.
Hmm. And there are, I mean, these insertion sort, bubble sort, and selection sort, they form one group. Okay, they are a little bit inefficient. That means they take a number of comparisons they take is not optimal. They used to take proportional to n square. Since we use nested loops. Okay, I am not going into that detail, but there are 3 more uh, efficient sorting algorithms for same purpose, as someone was pointing out: quick sort, heap sort, and merge sort. Okay, so they actually take n log n number of comparisons, log n based. Okay, so this is the optimal number of comparisons that any sorting algorithm can take in the worst case. Obviously, I mean, it is not for all input. Okay, I'm not going into that details, because the computer science students will uh, get this information or learn this analysis of algorithm in their third semester course, data structures and algorithm. Okay, but for the time being, for this course, you should know at least one way of sorting the element. Now, someone was pointing out bubble sort in the last class. The strategy is little bit different. Okay, instead of making a while loop nested within a for loop, we use for loop nested with a for loop. And strategically, let me just illustrate that with an example. Just strategy I am illustrating. I am not going to go into the detail. Okay, let's say the same input we are having 3, 4, 6, 8, 9, then 7, then 2, this is 2, 5, and 1. Now what bubble sort does, that it compares pairwise within this for loop, this inner for loop. It starts from this location, it compares pairwise. Now whenever it finds that left one is less than right one, that means when our target is to sort this array in ascending order, so that means they are in proper order, so it is left. Okay, now whenever this is not, that left side is larger than the right side, then it actually exchanges these values. Okay, so this is fine, 3 is less than 4, so it leave this. Now it goes to the next pair, 4 and 6, again it is okay. 6 and 8, again it is okay. 8 and 9, again it is okay. Now 9 and 7, you look, 9 is larger but 7 is smaller, so what it does, it exchanges their value. So now 7 comes here and 9 comes there. Okay, now in the next step what happens, this 9 and 7 again, 9 and 2, this was 2, remember, uh, controlling this was 2, so 9 and 2 again, this is not satisfying, so they will get swapped. So now 2 will come here and 9 will go there. Now in the next iteration of the inner for loop, these two will be compared. Since 9 again found to be greater than 5, again they will be swapped or exchanged. So here 5 will come and there 9 will go. And in the last 9 and 1, 9 will go there and 1 will go there. Okay, now you see, after this first iteration of the inner for loop, what is happening? The largest element, this 9, has been shifted towards right, or it has got its proper place, because in the ascending order, largest element will be placed on the rightmost side of the array. Understood? So this is called, as if the largest element has got bubbled up towards top. Okay. Now for the second iteration of this outer for loop, we will just consider the remaining portion of the array, because we have already got one element placed at its desired position. So next step for this outer for loop, next iteration, again all the iterations of the for loop will do what it will do, it will repeat the same thing. It will just pairwise compare starting from the first, and whenever it finds some disagreement with this order, it will exchange. So you will see that in the next iteration what will happen, second highest element will be bubbled up to the second rightmost position. So in this way, in insertion sort, what we are doing, we used to insert one element at a time in its proper position towards left. And in bubble sort, what we are doing, we are placing one element and in order, largest element first, then second largest element, then third largest element in their proper positions one by one. So strategically, this is the difference, and that's why their name also different. But at the end, you will be getting the same thing. And number of comparison wise, insertion sort is little bit adaptive. That means based on your input, difficulty of your input, the number of comparisons may vary. As you have seen, for some element, the inner while loop executes only one time or zero time, or for sometimes it executes a large number of time. But in for bubble sort, the number of execution is fixed. For any element, the number of execution will be, each time this for loop will be executed, first first time n minus 1, then n minus 2, then n minus 3, like that. Okay. But in the worst case, both of them will perform similar manner. That's why from worst case point of view, they are clubbed in the same section. Understood? So we may discuss this strategy later on our lab classes if time permits. Yeah. But you try to work them on. These are not very difficult to understand. If you find any difficulty, then you can also get back to us during the lab classes so we can discuss more. Okay. So before I conclude today's session, let me quickly introduce higher dimensional array. That means so far we have only considered one dimension array. That means this linear arrangement. Now there can be a tabular arrangement. There can be more dimension in the array. That is possible. Now I will just give a little bit introduction how to use them in C and then conclude today's session. So up to this it is okay?
Yes, sir. স্যার দুটো কোশ্চেন আছে।
হ্যাঁ
Yes,
বলো
sir.
বলো।
স্যার একটা হচ্ছে স্যার উল্টো অ্যারো কেন দিয়েছেন ইকুয়াল টু জায়গা, আর একটা হচ্ছে স্যার আমি ডান দিক থেকে বাঁ দিকে যাব অ্যারেতে, এটা কি করে জানবো?
ডান দিক থেকে বাঁ দিকে যাবে বলতে?
স্যার মানে স্যার প্রথমটাই তো স্যার প্রথমে ডান দিক থেকে তারপর বাঁ দিকে গেলাম অ্যারেতে, মানে কম্প্যারিজন করতে করতে।
হ্যাঁ,
স্যার
so
9 আর
so
2 তে
that's why the how you initialize these variables. Here for from left to right you are going. So you have initialized from 1 to n minus 1. And in insertion sort, what I have done? AI greater than key I have initialized to j minus 1. So that's how I have to manage.
ওকে
The
স্যার।
value of these variables will dictate in what direction I am moving. And I will be setting
ওকে স্যার।
that. That is the key thing in writing algorithm. So I have to know that what I am doing, I intend to do, whether I want to go from this side to this side or that side to this side, and based on that I have to set these conditions and set the initializations of this variable and their updation. That is the trick. Understood?
ওকে স্যার।
And this left arrow, actually this is not a program. This is called pseudocode representation. Okay, pseudocode. Probably Joydeep sir had introduced a little bit. This is just, you can use equal to also. Okay, this is just to differentiate between this single equal to and double equal to. Okay, in algorithmic term, single equal to is often in many books, it is written like this single arrow. That is, it indicates assignment. Okay. And the logical comparisons for which we use double equal to in your programming syntax, there we use equal to. Okay. There is no
ওকে
hard and
স্যার।
fast rule that you have to use arrow. But I have included them so that you can also understand. In some books you may find this arrow, in some books you may find this equal, because this description is independent of any specific programming language. So there is no need to abide by the rules and syntax rules of any programming language there. Okay,
ওকে স্যার।
understood? You can write single equal to here, no problem. Or you can even write j is assigned to 1 in word also. This there is no hard and fast rule of writing pseudocode, but there are some convention we used to follow. That's all. Okay.
ওকে স্যার।
Now, so as I have mentioned, the most natural extension of arrays is 2D array, which logically looks like a table. So so far, what we had a linear arrangement only. So we had several columns, but only one row. Now we could have both, I mean, more number of rows like this. This is a 2D matrix. So declaration will be like this. Instead of just mentioning number of rows, I have to also mention number of columns, because it is a two-dimension thing. Natural extension, you can easily see. So 1D, I had to only mention the row size, but since it is, I am intending to declare a 2D array which has both rows and columns, so I have to. So similarly, we can declare a three-dimensional element like a cube. There I have to also add another side, three sides, three dimension 1, dimension 2, dimension 3. Okay, I'm not going into that higher dimension, just 2D array which we'll be using very often. I'll mention that one. But higher dimension is also possible just by extending the dimension within this couple of third brackets. Okay. Now, how do I initialize? So see, you can always assume, actually inside memory also, we'll see a few slides after this, that although logically we consider this as a table, a 2D array, but we can also consider them as a long 1D array by placing the rows one by one. Understood my point? That means this first row 0, 1, 3, 4, then 5, 0, 7, 1, then 2, 4, 1, 9. So this is equivalent to this. You can consider. Okay. So initialization, see, you can do. You know how to initialize a 1D array. So each of these 1D array, as if this row, this is one D array, this is another 1D array, this is another 1D array. So you can write like this. Understood? All the elements, the complete initialization is done like this, or there is no need to write in this, no need to provide line break here. You can write in the single line, because these commas are there to delimit individual rows. Okay. So many people actually write like this so that the people who is reading his or her program can easily understand that it is a 2D array. But the same thing can be achieved by writing like this. Okay. Because they are same, you can see that this new line is not a delimiter. Delimiter is comma. See, comma is present in both of them. Clear?
Yes, yes, sir.
Okay. Now, when you put all the elements value in your initialization, that means you are completely initializing this value. You are not partially initializing. Huh? Then you can omit number of rows. In this, when you club declaration and initialization together, you can omit. Then also it will not generate any compilation error. Okay. Only, but this column size is uh, necessary. You cannot omit the column size for 2D array, and it is not recommended. Okay, because if you are not, in most of the time you may initialize partially, then it will generate error. This is only feasible if you completely initialize the array along with the declaration. Okay, but just for sake of your knowledge, I have mentioned that. Now partial initialization is also possible, but here in almost all compiler you find that the I mean the elements which you have not mentioned, they will be automatically initialized to 0. Like for the first row, you have already initialized first two elements, 3 and 1. So remaining two elements will get 0, which was not uh, guaranteed. In case of 1D array, we have seen it depends on compiler to compiler. But here, in almost all compiler, you will find that remaining elements for partial allocation will be initialized to 0, like this. Okay. Similarly, you can keep the entire uh, row to be initialized by 0 like this by putting a single 0, or even you can keep an empty pair of braces that will initialize all 0. Okay. So this and this is also equivalent. Okay. Similarly, if you miss the last row, see, it should be contiguous. You cannot miss the second row. You see, understood? Because any initialization, as in case of single dimension array we have seen, it should be from as left as possible. Similarly, here also you can partially initialize, but the partial initialization will continue from the first row to some row. You cannot miss any intermediate row. That is why it is not possible for compiler to understand. When it gets to initialization, it knows this is for the first row, this is for the second row. So third row will be entirely allocated to 0. Understood? These are the tricky thing you need to remember. Now, complete initialization. If you want to complete, these are the shorthand notation. Just like for single dimension array, we had encountered x6 equal to only 0. Huh? Similarly, this thing can be done also here. If you want to completely initialize all the elements to be 0, these are the two options. Okay. This is the last one. Hmm? What will be the consequences of this type of initialization? This. Okay, so leave this initialization. You can also try of your own to understand how this initialization happens. With you can play with this type of several options and check the output. Okay. Now accessing individual elements. See, now you have two index you have to use: row index, column index, because you have two dimension. So each and every element will be identified by its row index and column index. It is quite natural because it is a two dimension thing. So x1 2 will indicate row 1, column 2. So row 1 is this one because row starts from 0. So 1 means second row and column 2 means third column, this one. So that will be uniquely identify this cell of the array, 2D array, and you can easily access. So indexing here needs two indices, row index as well as column index. Fine.
Yes, sir.
Yes, sir.
For reading, writing, whatever you want, you have to explicitly use these two indices. And memory representation, I will conclude by showing the memory representation. As I have already mentioned, since our memory is a linear arrangement, which is itself a 2D array, and we have already said that the number of columns is fixed to 8 bits in the logical organization of our RAM. And we have seen how we can fit in, or actually operating system actually store an array. It just reserves contiguous spaces, sequential uh, bytes for presenting 1D array. Now how it can present 2D array? Unless it internally gets converted into an 1D array, as I have shown in the very first slide of this discussion, this one. So if I can logically think that 2D array is basically get internally converted to an 1D array by placing rows one by one. Okay. So I can easily now relate how the memory arrangement can be done for 2D array. Okay. So this is done. The logically this equivalence is used. And now you know this is the first element. so there will be some starting byte. From there, these all the elements will be stored like just like 1D array case. Okay. So now obviously each of these elements will be now identified by both their row index, and instead of x0, x1, x2, x3, it will be x00, then x01, x02, x03. Then this is x10, x11. In this way indexing will go. Since this is a 2D array, so their equivalence will be like this. And the for random access, now the formula will get changed a little bit. Look at this. You just relate with the formula. Here we have to use both I and j. Earlier we had only one I. Okay. And so the C is same as earlier, B is same, B is the base address, which is now not, which is indicating this address 00. Okay. And so number of columns into I plus j. For calculating or locating the position of the item or member xij, the address will be calculated following this formula. Base address, that means ampersand x00, which is the base address, or B, this is equivalent to B. Then plus C, basically for integer array it will be 4, whole into number of columns. Number of columns here 4. Number of calls into I plus j. Okay. So in this way it will work. Just internally you think it is getting converted into a single dimension array just by placing. Similarly for higher dimension array, 3-dimension array, that will be done recursively. Okay. So every whatever may be the dimension of the array, each of them will be internally converted into a linear arrangement by placing rows one by one. Okay. And then in this way the memory representation will work. And this formula will be little bit updated for higher dimension, but following the same philosophy. Hope it is clear to you.
Yes,
Now
sir.
you have got enough information to deal with at least 1-dimension and 2-dimension arrays, which are very common uh, for all sorts of numeric inputs. But for character inputs, has some special needs some special attention. That means character arrays, which often are termed as strings, which needs a little bit different attention. Along with that, I mean, something will be carried forward. Some concept will remain same. Character arrays will be also, memory representation will be same, similar. Their initialization rules will almost follow with some little bit exception, which Joydeep sir will start discussing from the next Monday. Okay. So if you have any question, you can take a few questions and then conclude today's session.
Sir, can you repeat that? B plus C into number of columns into I formula.
This one,
Yes.
you can just try to understand what is happening. You have converted this 2D array into, this is internal arrangement. Logically, for a programmer side, you know the column index and row index. Understood? So now using that, how and you can compute the address of a particular element. Now see, since the rows are placed one by one, 0th row, then 1th row, first row and then second row. So see, if your base address starts from anywhere without loss of generality, here it starts from 1000. Now for any ij, let's say you wanted to go locate 2, 3. Now see, you have to, this number of columns input is important because since you are looking for second row, already you have to go past by all the elements of the 0th row and all the element of the first row. Now what is the size of each row? Size of each row is basically number equal to number of columns. Understood? So whenever you are targeting second row, that means you have to go past two rows, 0th and 1 first rows, and whose size is, each of them size is I. So that many number of steps you have to jump, plus then you will be reaching on that particular row, second row. And on the second row itself, how many elements you have to jump, that will be dictated by this column index, this 3. Then only you can reach to that particular location. That's why this is.
Okay, thank you.
Any other question?
স্যার বলছি একটা অন্য কোশ্চেন আছে
বলো।
স্যার আপনি লিনাক্সে বলেছিলেন ম্যাথ লাইব্রেরি ইনক্লুড করার জন্য -ln লিখতে হয়। স্যার এরকম আরো জিনিসগুলো আমি কোথায় পেতে পারি?
দেখো লিনাক্সে সবচেয়ে হচ্ছে ম্যান পেজ করতে হয়, ম্যানুয়াল পেজ আছে, ম্যানুয়াল পেজ এক্সপ্লোর করতে শিখতে হবে লিনাক্সে যদি করতে চাও। আর মানে ইউজুয়ালি তোমার লিঙ্কিং এর জন্য আলাদা ম্যাথ লাইব্রেরিতে লিঙ্ক করতেই ওটাই একটা বাগ আছে আর কি সিস্টেমে, -lm দিতে হয়, নাহলে অন্য লাইব্রেরি তুমি জাস্ট ইনক্লুড করলেই অটোমেটিক্যালি ইনক্লুড হয়ে যায়। ম্যাথ লাইব্রেরিটার জন্যই তোমার লাগবে -lm। আর অন্যরকম অনেক জিনিস তোমাকে ওই ম্যানুয়াল ঘেটে ঘেটে দেখতে হবে, অথবা তুমি লিনাক্স ফোরাম আছে, উবান্টু ফোরাম আছে, তুমি সেখানে গিয়ে প্রচুর দেখবে ওরকম কোয়েশ্চেন অলরেডি আনসার্ড হয়ে আছে, তুমি সব পেয়ে যাবে সেখানে।
আচ্ছা স্যার।
ঠিক আছে।
হ্যাঁ স্যার।
So if there is no more question, we can stop and we can conclude today's class. Okay.
থ্যাংক ইউ স্যার।
Okay.
Thank you, sir.
Okay.
Thank
So
you, sir.
Thank you, sir.
থ্যাংক ইউ স্যার।